Yeah, I can hear you loud and clear. I don't think so. He's actually out of the office this week. So, yeah. Cool. Okay. Should we get started? Amazing. Okay. Okay. Let me share my screen. Hope everyone's doing well today. Apologies, couldn't be there in person. Okay. Sorry. Wrong one. I meant to hit slideshow. Okay. Can you guys see this okay? Awesome. Now, so just wanted to introduce myself. My name's Andrew. I'm a solutions architect at Groq. This is Groq with a Q. We're a fast AI inference provider. Maybe show of hands, like how many people have heard of Groq? Okay, like a good number of hands. That's cool. Um, so I'm going to be sharing a little bit about Groq today, show you some demos, show you how easy it is to implement Groq in your applications. I'm going to use an example from Cursor, of course, and love to make this as interactive as possible and to take any questions you may have, right? Whether you've got questions about use cases that run well on Groq or anything of the sort, please shoot them at me. Okay, I'm based in Singapore, by the way, right? So pretty nearby. Now, so I think the key point that I want to let you guys take away today is that it's really easy, cheap, and fast to build on Groq, right? And how often do you get faster, cheaper, better inference? It's rare, right? And I'm going to be demonstrating that. And I really just I'm hoping that you guys get this takeaway out of this workshop and session. What Groq is, we provide fast inference. How we do this is with our LPU, which is a different processing unit that's an alternative to GPUs. I'll go into a bit more detail about how the LPU works later on, but we have a heavily differentiated inference speed because we're running leading open source models on our different hardware that's non-NVIDIA based. I think if you've been following the news, you'll see there's a lot more attention on non-NVIDIA chips these days, whether it's Google's TPU, whether it's AWS's chips, whether it's the chips OpenAI is trying to build. And Groq, we've had a long history of building our own chips that provide lightning fast inference. By the way, our founder, Jonathan Ross, was the creator of Google's TPU. So he comes from, he has like heavily credentialed and experienced in chip design. And he started Groq about 7 years ago after a couple of generations of TPU hardware at Google. I think what I'm going to do now is to use some demos to illustrate the speed to make it feel a bit more real, a bit more tangible what speed differences mean, and hopefully get you guys thinking about what that means for the applications you're going to be building this weekend or after, right? I'm going to use an example here where I'm comparing a number of different models in terms of the output speeds. Let me just clear these first. We'll use the Llama family models, and I'm going to ask the models to generate tokens, right? And here we're just going to be comparing it to sort of best-in-class NVIDIA inference running on NVIDIA NIMs versus text boxes that you see in orange, which are Groq-powered LLMs. Maybe I should give him a moment. Okay. So basically, you see the Groq-generated LLMs, the Groq-powered LLMs generating tokens much faster, near instantly. Okay. I realize there's a max token truncation here, so if you're seeing any weird outputs, I'm just going to run that again. So you, now that maybe you've seen it once, you can watch it again. Let's see if I can right here. See. You just see that the Groq LLMs running on Groq generate tokens significantly faster than the alternatives. So this means that you could almost generate tokens as fast, and you could complete a check completion, for example, in the time it takes an alternative inference provider to generate the first token. How that may be useful for your applications, I think it's in certain voice applications. Anything requiring a lot of user interactivity would really benefit from fast inference. I'm going to show a couple more demos. Now here, we combine fast inference with fast tools like web search, optimized web search, for example, right? So I'm going to show an example, just asking some questions. We'll do the speech to text. We'll ask one of our models called Compound Mini a number of questions, and it's going to run fast web search and tool calls to generate an answer really quickly. So let's try this, right? Hey, can you tell me about the Cursor hackathon that's happening in KL on the week of December the 5th? So it transcribes this near instantaneously. Now it's doing a bunch of tool calls and it's generating the output really, really quickly, right? So you see it did 2 calls to search, and it found, I think, a number of results across Instagram, Facebook, X, other event websites, Luma, I'm sure. And it generates a summary based on the web searches really, really quickly. I think that was maybe 2 or 3 seconds, right? Let's see if we got the updated dates, but I think it did. Okay, yeah. But you've got like the Luma links here. You've got devpost.com, and I think you've got a list of the prizes. I'm assuming this is correct. So just an example of, maybe things you could be thinking about when you have access to fast LLMs and fast tool calls. You could gather a lot more information. You could ask the LLMs many more things. You could assemble a lot more information retrieved very quickly into outputs that are useful for your users in a very, very short amount of time. We've also got speech-to-text and text-to-speech models running on Groq LPUs. I don't know.
Below is a compact, action-oriented briefing for the Cursor X Anthropic Hackathon that takes place in the Kuala Lumpur area the week of 5 December 2025.
So we've got all these models running that I'm going to show you how you can access on Groq, right? So I hope that was a good illustration of the speed and hopefully got you thinking maybe a bit about what applications may benefit from low latency LLMs, right? We're approaching the speed of, we're not at the speed of database queries yet, of course, but we're being used increasingly in near real-time applications. So I think that was a couple of demos. I'll show you a few more things afterward on how to access and use Groq LLMs. But just circling back a bit to how we achieve these speeds, about 7 or 8 years ago, we started working on a chip called the LPU that's inference only. So we don't try to build chips for training. There are a whole bunch of different mathematical operations in LLM training, computing gradients and otherwise. What we're doing is inference only. So largely a series of matrix multiplications and different mechanisms that are needed. And how we achieve this higher speed in a bit more detail is by 4 things primarily. So on-chip memory. So you remove memory bandwidth constraints associated with moving data between high bandwidth memory and GPU cores. We've got a deterministic compiler. So everything is clock synced. There's no waiting on threads or locks. once the LLM starts processing, once the chips start processing token generation, right? We are also have more parallelism through proprietary chip-to-chip interconnects. That means this can help us achieve more memory bandwidth, even though we have less memory per card or per node, right? So that's just a bit of the theory. I think it's really abstracted away from the developers by a large margin, but sometimes we do get questions around, hey, why is Groq so fast? I think this is a quick summary of it, right? I think one of the questions we often get is Groq quantizing models? I think the clear answer is no. There are some elements of models, like maybe MOE weights, that do get quantized, but not anything that affects the accuracy of models. We also have specialized multiplication units within the chips that in some cases can provide actually more accurate results, right? There's less like error propagation, accumulation. We transform some of the MAC operations to fuse, multiply, adds, and a number of different things that we're doing to have actually more accurate numerics. So again, if any questions about that come up, if there's anyone curious about the low-level stuff, please feel free to ask a bit later on, right? But this is how we achieve high inference speeds, and it's only going to get faster as we roll out newer and newer hardware. In fact, the current chips that we're using to generate speeds that are faster than best in class today on GPUs are a number of years old already, and we're going to be upgrading those very soon. Now, how do you use Groq, right? So I think it's really, really easy to use Groq. We integrate with all the major frameworks, the popular frameworks like LangChain, Llama Index, the Vercel AI SDK. So it's really easy to get started. We even are compatible with the OpenAI Python SDK or the TypeScript JavaScript SDKs. And I'll show you a quick example of that, right? So we support the chat completions API. We also support the responses API, which is getting increasingly popular for a number of reasons, right? It's you get to pass the reasoning traces back in easily. It makes the tool calling syntax a little bit simpler. So we do support both the chat completions API as well as the responses API, which are the OpenAI compatible standards. Now, we've got a number of models available on Groq. These include, speech to text, text to speech, text to text, image to text. What we don't have is a text to image and text to video. I think for those, folks that, people like to use Nano Banana or other such models, we don't have any text to vision, text to image or video models. Okay, now I'm gonna just do a quick demo now of using Cursor and Groq, right? Here, let me open. Now, okay, so here I've got Cursor open. I'm using the OpenAI Quick Start, Python Quick Start. I'm going to zoom in a little bit, right? And here you'll see that OpenAI provides an API Quick Start that shows you how to use the OpenAI Python SDK to call OpenAI LLMs. Here, from OpenAI, import OpenAI, and then create a chat completion. Now, I'm going to just show you how this looks as out of the box, and then I'll show you how we can use Cursor to kind of one-shot it and teach it and tell it how to switch to using Groq to accelerate the inference, right? The OpenAI API Quick Start comes with 3 examples. I'm just going to be using the Chat Basic example, right? So you see I'm in Chat Basic, and I'm just running the Flask app. Okay, this opens in Cursor. They've got this little browser functionality. It's running dark mode, you won't see this, but we can just chat directly with the OpenAI chat completions endpoint. right now, right? So we'll say something like, let's say 250 quid, right? So just a simple Flask app. I mean, I don't think this is what you may necessarily build over the course of the weekend, but just using an example from a standard quick start. So now GPT-5, as you know, takes a bit of time. Here I've just set it up to use GPT-5, right? But as you can see, we're going to be waiting for a few minutes. Not for a few minutes, but let's say for like 20 seconds before it generates a response. Okay. So that's GPT-5. Now, with using Cursor Composer, I'm going to say something like in that basic switch to let's see, OpenAI, GPT versus model. And then something like change the base URL, model name, and load credentials from that. Right. I don't know if folks have used the composer model or you're going to be using the Anthropic models, but both would, all of them work really well for these kinds of tasks. I mean, Cloud Code is great, right? but we'll just use Composer, which is also very good and very fast, right? So basically, it's going to say, hey, if you want to load your credentials from .env, add python.env. And then let's see what the changes it made, right? So it just made it only made a small number of changes. So add a base URL and API key, and just load .env just because I want to use that to manage the credentials, right? And then it switches the model here, right? So I'm going to just say keep these changes, keep these changes. Okay, I'm going to say I'm going to pip install the updated requirements. And then I'm going to run this now, right? So let's see. Tell me a story. Yeah, I'm going to type 1,000 words, right? So I'm going to hit that. So you see, it just generates tokens pretty much instantly, right? When running on Groq. Now, this is even faster than the fastest OpenAI models like GPT-4o Mini, 5o Nano. We were like 3 to 5 times faster than those models as well, right? Of course, in this example, the markdown is not formatted correctly because it's just a toy example, right? But that's an illustration of how easy it is to switch to using Groq. Using standard libraries, you don't need to install. We've got our own Python SDK, but you may not need to do that, right? We can even do something like switch. Okay. Okay, so it updated. Let's say if we want to use the Compound Mini because we want to do some very fast web searches, or use any functionality available in Compound. Let's see how that looks. Right? So in this case, Cursor is doing some web searches to figure out any additional syntax that may be needed to add these as parameters to the model, right? Searched. Okay, let's see if Cursor is right. Yep. Yep. So cursor in this case didn't get it right. I think this is the correct syntax. Okay. Okay, I know why this is the case. It's because the OpenAI SDK doesn't allow some, like random extra parameters that you may need. So you could do something like if you were trying to just provide more information to, say, our compound model to using it to do web searches, right? So, I mean, the simplest example of how some folks are using this is for, say, scam detection, right? You want to verify information against a web search, then you want to be able to do web searches quickly. So scam detection, WhatsApp chatbot, for example, is a popular, simple use case that may use web searches. Right? Yeah. So even with the web search, you see. Okay, I don't think this may or may not be right. Okay, we'll come back to this example. Right now, an easy way to get started playing around with Groq is to sign up for an account. Right. So if you go to console.groq.com and you just sign in with an account. If you go to console.groq.com, you'll see create an account or login. And if you just hit continue with Google, it would create an account or let you sign in. Just note that Outlook.com accounts and Hotmail.com accounts sometimes trigger, let's say, abuse prevention. It's better to use a Gmail account or any other kind of account that's not Outlook or Hotmail, just in case, right? Or if you use Outlook and you end up running into some issues creating an account, maybe try using a Gmail account. Now, up on the top nav bar, you'd see playground, and the playground's meant it's meant to make it very easy for you to test out different models. So if I've got the OpenAI GPT OSS 120V model, which is very popular, I can just test out the syntax, and then I can copy out any code snippets that I need and copy that into the application I'm building, or just copy it into another code editor or Cloud Code or Cursor assistant agent, and they would be able to help you implement that in your own application. Right? So it's like now I'm not, well, it depends on which models that you are thinking of using, but each of them may have different settings available. For example, the GPT models running on Groq have built-in tools because they were trained to know how to use a code interpreter and browser search. The compound models, as I mentioned earlier, also have a whole bunch of functionality around web searches, browser automation, and otherwise. Right. So I think another quick tip on using some of the GPT OSS models is the reasoning settings are customizable. You can't turn off reasoning because they are strong reasoners. But if you wanted like slightly lower latency, you would think about setting reasoning effort to low. Right? Right. So what's nice about using the playground is you get to see what tools are being executed. So we run this tool loop on the server side that calls, browser search, browser open. So in this case, the browser automation actually opens pages. It's not just like an indexed web search. generates results, and then the model generates a final response after making like 10 tool calls in about less than a second, right? So cursor anthropic hackathon Malaysia 20. Right? Now, the so it just makes it very easy. The playground's meant to make it very easy for you to copy out snippets into your application and for you to test out the different models that we have available on Groq. I think what's also quite interesting here is something called the MCP servers, right? So I think there are lots of different ways to implement MCP servers and clients. Here's an example of us facilitating using tools and functions exposed by remote MCP server. So in this case, Hugging Face has an MCP server running, and just across all our models, if you provide a tool of type MCP with the server URL, you then have access to functionality exposed by the MCP server. Sorry. Hugging Face in okay. So again, near instant generation. It calls a number of tools that the remote MCP server makes available, right? So with the MCP, there's a tool discovery step, and then the model decides which tools to call and calls the tools, and we facilitate that on the server side. So based on the trending score, as everyone would know, V3.2. But if you went on Hugging Face, I'm pretty confident these are the results you would see as well, right? Because this is Hugging Face's official MCP server. We do also have MCP connectors where you can connect to your own Google Drive, calendar, or inbox via Groq. Those are connectors because there's actually an MCP client that's running in Groq, right? There's no MCP server provided by Google themselves. It's called MCP connector, right? So I think there's some different approaches when you're using MCP servers. There are also some third-party examples like not browser use, but browser base is a hosted MCP server, but it's via Smithery, right? So there are a number of different ways to use MCP servers. I don't know if that's something you guys are thinking of building. And again, happy to dive into how this may work. But suffice to say, we do allow accessing remote MCP servers easily to Groq. And because the MCP tool calling loop is handled on the server side, it runs much, much, much faster, right? Some of the criticisms of the MCP are, it can slow things down. And now you can run into issues where there are like 100 MCP tools or functions that add to your context length quite heavily. In this case, we handle it on the server side, and in cases you'll also be using more than the maximum context length if you're using this like React loop for accessing MCP tools. But we try to make it as easy for devs using Groq to use various MCP servers. Okay. Any questions about MCP? I know it's like a hot topic that folks that may have experimented with or not. Mm-hmm. So there's no additional cost for using MCP servers. It's just that the tokens are charged, like input and output tokens does tend to increase when you use MCP servers, right? So like maybe the Hugging Face MCP server exposes 10 tools. Let's try this, right? So we say what tools are available. So you see here that the Hugging Face MCP server provides 1, 2, 3, 4, 5, 6, 7, 8, 9 tools. And if you were using a remote MCP server, you would kind of think about it as you automatically then have 9 extra tools inserted into your context. So the input context increases, and therefore you will use more tokens. There's no extra charge for using the MCP server itself, right? Just you will tend to use more tokens, which may or may not be an issue. I mean, input tokens, especially if they're cached, are quite cheap, especially on Groq. It's like, 15 cents for cached input tokens on GPT OSS models. Yeah. At the same time, for tooling like web search, there's an additional cost, right? So it's $5 for 1,000 web searches, right? So it's like 0.5 cents per web search. It's not a huge amount of cost, but for server-side tools, sometimes there can be a cost associated with a web search or browser automation. Internally, we actually implement that via MCP on the server side, but that's just an implementation detail of how we access web search ourselves. And running everything in a tool calling loop on the server side keeps things very, very fast instead of having to go back to the client or local application multiple times. Yeah. I hope that answers the question. Cool. So on the topic of pricing, I think it's let's see pricing. Our pricing is all publicly available information, as well as we provide a TPS speed on our website because our architecture is deterministic, where we can consistently get exactly the same output token speed. Now, how long the check completion takes is a function of how long the input context is, because that takes a certain amount of time to read and increases with more input tokens. But at least our output token generation is highly deterministic, so we have put these exact token per second speeds on our website. The input and output token prices are here, and for models that support caching, the tokens are like discounted by 50%. It's useful to think a little bit about, in building your applications, how you structure your input prompts to take advantage of caching that's available on many inference providers. Like caching reduces costs and also it lowers the end-to-end latency because you're loading the key value cache values from memory. Okay, and caching happens in blocks of your input context, and we match that, and that's cached to just reduce the processing time and cost. Now, one common question is also, what models do you like? How do you decide on a model to use, right? I think everyone has their own personal preferences around models to use. What we see people using on Groq is very high volume and low latency. For like high volume and low latency use cases, folks like to use a number of different models. There's the GPT OSS models, which are really, really strong reasoners. You have Kimi K2, which is like a very large model that's very good on long context tasks and tool calling. You have the Llama 4 models, which are vision enabled. Are they as good as the state-of-the-art vision models? Admittedly, maybe not, right? But they still run very fast and cheap on Groq. We've also seen like folks using safeguard models or guardrails. I know it's not the sexiest use case, but it's quite useful to think about how you can use LLMs to check input and output for safety, ethics, and a whole host of other things. We've got Llama Guard and Prompt Guard as well. That again are very useful in, I'd say, use cases that require a higher level of governance applied. Right. I think the fastest model on our platform, the fastest models on our platform are the GPT OSS 20B model and the Llama 318B instant. I know 3.1 sounds like it's very old, but this is really, really, really fast model. And without reasoning, the TTFT on the content tokens is very, very fast. So that should give you a quick overview of the different models available on Groq. Going back briefly to the pages, I wanted to share again a bit about our compound models eval pretty well on availability to retrieve the latest information, so the latest news. In one of the evals, it also ranks higher than the perplexity models at web search and information retrieval. To get started again, just hit console.groq.com. And really, it's as easy as 3 lines to get started, as I demonstrated in the cursor example earlier, just now. If you want to get started, even without putting a payment method or credit card, there are free tier limits to get you experimenting with Groq, just to try it out. And this will give you access to all of our models, albeit with slightly lower rate limits. If you wanted to unlock the high rate limits, you'd need to add a payment method, and then they get you very generous rate limits that should be enough for any of the applications you're building. Okay, now for this hackathon, the process to get Groq credits is, I think, I mentioned earlier we've got a free tier, which it's perfectly functional. It's fast. It's very fast. It's fast enough for the purposes of building for hackathon. But if you encounter rate limits, you're going to want to sign up for our developer tier to unlock the rate limits, and then share your email so you can get credits applied to the account so that nothing's billed to you. And those credits, you can use them after the hackathon as well, right? You can Now, what this means is that if you're keen to use credits for this hackathon, please share your email with the organizing team, and they'll give it to me, and we'll apply the credits by this evening, right? In the meantime, you can already get started trying it out, trying out the different models on our free tier. So if you sign up, share that email address with us, and we can apply credits to the account that you'll see in your account. But to get the credits applied, you would need to have added a payment method or credit card, right? Does that make sense on what the process is for getting credits? Okay, awesome. Okay, now we've got a whole, a number of different demos. There are lots of demos floating around of people building on Groq. What I recommend is a couple of GitHub links. I'll share them later on. Once Groq/Groq API Cookbook, and another one is we've got Groq/Groq API Cookbook. We've got Build with Groq. So it's an organization on GitHub called Build with Groq, where there are lots of different templates, including voice agent templates or otherwise. Lots of different examples here. We've also got devpost.com software built with Groq, right? So you can see a bunch of examples that people around the world have built with Groq. I don't know if this is fully updated or not, but there are lots of different examples running around in the wild of how people are building on Groq, right? We've got, we're happy to showcase any interesting projects that you build. Just feel free to reach out to me or devrel@groq.com after the hackathon. We love sharing about the work that folks have done to build on Groq. We've got a community site as well, where people ask questions, and that's also quite a useful resource. Some folks troubleshoot on our community website as well. We've got about 2.5 million devs around the world building on top of Groq, and lots of startups, digital natives, enterprise customers building on top of our APIs as well. So just want to thank you. I think that brings me to kind of the end of what I wanted to share. Thank you so much for taking the time to join the workshop. I think we've got a bit more time. Feel free to ask any questions. If there are some things you're curious about, ideas that you want to build, more demos you want to see, I've got a bunch more. Yeah. A great question. So you're right in that Gemma 2 has been deprecated. We have the 9B model. I don't think the newer Gemma models will be brought back. There's just a bit less interest in them from the community, at least for the open source models. Is my opinion on why I don't see it coming back. There are lots of interesting open source models. I think primarily the Chinese ones that we have all running fully internally, like Minimax, Kimi K2 Thinking, GLM, and all of those. All of them run really well on LPUs. It's just that we haven't released them because, like many other inference providers, we want to make sure there's a certain amount of capacity available, and globally with the existing model fleet, we're already serving trillions of tokens, and we're just being a bit careful about how quickly we release new models. Otherwise, the demand is overwhelming. Yeah. On the second question, on multimodal models, I think if you were building for this weekend, like we've got Llama 4 Maverick probably being our best vision model. We're going to be replacing this with a better vision model very, very soon. There are a few popular open source ones. That's what I recommend if you wanted to build something today. In a few weeks, there should be some updates there on multimodal models. If you were thinking a bit more about multimodal applications in like voice to speech to text combined with LLMs, I think one of the frameworks we like is LiveKit. So Groq and LiveKit work pretty well together. So we use let me find it. Let me find the template there. Yeah. So we've got we've got the Groq voice agent template. This is one example of using Groq APIs for voice applications. This doesn't use LiveKit. There are a few different examples in the Build with Groq org around using voice templates. Two popular frameworks for this are LiveKit and PipeCat. Both work pretty well with Groq, and give you some control over the choice of STT, the choice of LLM, and the choice of TTS model. So you could combine it with something like 11 Labs where relevant. Yeah. So that's I hope that kind of answered the question in that we don't see more Gemma models, at least in the very short term. Right now, from vision model, we've got Llama 4 Maverick. There's some updates coming there soon. And for speech to text, typically it's done in the context of a different framework like LiveKit that handles like the WebRTC or WebSockets to get the audio bytes to Groq for very fast transcription, about 200-300 milliseconds. Yeah. Great question. So I think there are a number of them. One is any like contact center type applications. So any voice enabled like call center applications, they benefit from fast transcription and fast LLMs. And in some cases, this just means our whisper models are listening on a call, transcribing it very quickly, and providing real-time suggestions and updates for anyone in a call center or contact center. And I think you'd be surprised by how many call centers there are out there. That's one popular one. I think anything that requires like good user interactivity, like we have there's like a healthcare AI startup that has this WhatsApp chats where you can ask lots of questions. Anything that just wants to cut down the latency by 3 times would really benefit from Groq inference. One of the use cases I like a lot is around guardrails. So we work with like these large gaming companies who want to moderate a lot of content on chats in real time. And they want to moderate content, including very creative users coming up with like obscene usernames, group chat names. So it's really simple use cases. You just want to use it LLM to check it, right? And people are so creative that a lot of like content can escape typical like text model classifiers. So they want to use LLMs to do content moderation. That's one I've seen becoming increasingly popular. There are some industries that are just using us for not so latency sensitive applications because it's just cheap. So there are folks that just use us because of the very, very low cost and high reliability. I could go on, but I'll just like pick one or two more. A lot of product builders use us. So one of my favorite case studies is Mem0. I don't know, anyone heard of Mem0? Mem0 is like one of the most popular agent memory frameworks, right? So Mem0 is open source package, but Mem0 also has a managed cloud offering where they help you manage memory for your agent. So if you've got a chatbot, Mem0 helps your chatbot remember what I said 5 months ago, right? But under the hood, Mem0 uses Groq to quickly decide what gets inserted into memory. It uses Groq to quickly summarize conversations to generate memory. And it uses Groq to determine what retrieved memory is most relevant to a conversation, right? So Groq powers a lot of these really, really interesting like products. And we're sitting kind of in the back end. You don't hear of Groq powering them, but we power like some of the best tooling for agent memory and otherwise. Anything that just requires really fast inference. Yeah, lots of productivity tools, voice agents. The list goes on. Yeah. Great. Thank you so much for taking the time. It's a precious 45 minutes for everyone. And good luck with the building this weekend. And let us know what the email addresses are to apply credits to. Yeah. Okay, there was one more question about bouncing ideas. I'm happy to stay on the call to take that one, or you can send me another link or something, or shoot me a WhatsApp maybe. Yeah. Okay, thank you.